far in this module, we've learned about solving systems of equations by graphing and then by using substitution. So today we are going to learn about the elimination method and more specifically adding and subtracting when using the elimination method. So the first thing that we want to do is define what the elimination method is. So the elimination method is when one variable is eliminated. So we are going to try and get rid of it by adding or subtracting, and we'll talk about how we know which one to use, two equations in the system. Okay, so we're going to just keep practicing this. So again, before we talked about substitution. So substitution is beneficial for when you have a variable by itself, meaning a coefficient that is 1 instead of a number other than 1. So looking at this first one, we want to see what looks alike. Like to me, these y's stand out right away, right? We can see there's a 2y and a 2y. So I'm going to eliminate them. Now we have to decide, our first question is, do we add these equations or subtract them? If I subtract them, I'm going to just get negative 2y and positive 2y, which would be, or negative 2y minus 2y, which would end up being negative 4y. So that doesn't help us. So we are going to add them. So when I add them, I get 4x plus x, which is 5x. Negative 2y plus positive 2y cancels. And then 12 plus 8 equals 20. So what happened was we just eliminated the y completely. So now we're just going to solve for x by dividing by 5. And so the 5's cancel, and you just get x equals 4. So just as a reminder, when we are solving system of equations, we're trying to figure out the point where they intersect. So far we've only found the x value, so we still have to find the y value. So what I want to do is plug in that 4 into either equation for x and then solve the y. So if I plug it in to the first one, it would be 4 times x, but our x is 4, minus 2y equals 12. And it actually probably would have been a little bit simpler to plug it into the second one, but it doesn't matter. So 4 times 4 is 16 minus 2y equals 12. And then I'm going to go ahead and subtract 16 from both sides. So the 16s cancel, and I get negative 2y equals 12 minus 16, which would be negative 4. And then I can divide by negative 2, and negative 4 divided by negative 2 is positive 2. And so when we write our final answer, we actually want to write it as an ordered pair because it's a point. So if we were to graph both of these lines, they would intersect at the point 4, 2. All right, looking at our next example. So again, the first step is deciding, well, what variables do I want to eliminate? So looking at this, it's kind of obvious. We want to eliminate the x's because they are the same, right? 2x and 2x. So then we have to decide what operation. So we have to think, if I add these together, that will just create 4x. But if I subtract them, that would eliminate them. So 2x minus 2x would just be 0. 6y minus a negative y is 6y plus y, which would be 7y. And 6 minus negative 8 would be 6 plus 8, which would be 14. And then we divide by 7, so y equals 2. And then from there, I would plug that into either equation. Doesn't matter which one. I'm just going to use the top one. So 2x plus 6 instead of y, I'm going to substitute in 2. And then we keep simplifying. So 2x plus 12 equals 6. And then I will subtract 12. So 2x equals negative 6, and then divide by 2. Negative 6 divided by 2 is negative 3. So our final answer would be -3, 2. We also could write a little note, something that might be helpful, which is if we have basically if we have different signs, we want to use addition. And if we have same signs, we want to use subtraction. Okay, so different signs, addition, same signs, subtraction. So think same, subtract. That might help. Okay, so this one is a practice problem, which we're going to go over in class, so I'm going to skip that. And then we just have a couple more examples here. So these are solving special systems. So if you remember when we looked at substitution and also graphing, we had one solution, but then we also could have no solution or infinite solution. So we are going to see what that would look like when we're solving using elimination. So step one is, what are we eliminating? Well, we can either eliminate the x's or the y's looking at this. They are all the same sign, so same is subtraction. So I'm going to go ahead and subtract these. So I know when I subtract, I end up getting nothing, right? That cancels, that cancels, that cancels. So essentially we have 0 equals 0, and 0 equals 0 doesn't really make sense, right? Because we didn't get x equals something, but 0 equals 0 is true, which means that, sorry, I don't know why I put E. This would mean that we have infinite solutions. And looking at the equation, that totally makes sense because they are exactly the same. So you can also kind of use some reasoning, right? They have the same exact equation, so when we graph them, they're going to be overlapping. All right, next one. What variable do we want to eliminate? Well, it actually doesn't matter again, right? They're all the same. We have the same sign, so we're going to go ahead and use subtraction. So those will cancel, and then -2 minus 4 is -6, and I know that that's 0. So 0 doesn't equal -6, first of all, and then also we eliminated our variable completely, so that tells us it will be a special case. And in this case, since it's not true, we would just say no solution. So that means if we were to graph these lines, they would be parallel lines. So therefore, they would not intersect at all.